Hello friends, welcome to today's video on mastering the e-commerce database design. A well-crafted database is the backbone of any successful online application. So today what we are going to do is we are going to explore our e-commerce database. We will examine how thoughtful design impacts the performance, scalability and the overall user satisfaction. So come, let's get started. Now, first, we have to think about the requirement. So understanding the e-commerce requirement is important. So in an e-commerce system, generally, we have various key components like products, category, users, order, payment, and so many other stuff. The bigger the e-commerce, the bigger the database design is. So we are not going to do all of those real, the company related stuff, but we will involve fair enough tables that is really used in our application. And when we finish our application, right, it will be a small e-commerce application. You can literally start your business if you're interested. Anyway, now each of the entities plays a crucial role in delivering a seamless shopping experience, so everything is important. Now we have to be making sure the data integrity and security also is considered into the picture. Okay, see here in this e-commerce database design, I will not be teaching what is SQL and all of those things. So assumption is you already know SQL, at least to some extent, like at least the create table, update and all of basic things. I assume you will know. If you don't know, it's okay. Put it in the comment section. I will dedicatedly put a separate video on how to use SQL and learning of quick things in SQL. Alright, so let's assume that you already know something about SQL and we're going to see how we can design a database. Now, if you consider this diagram, right, we have so many entities. Literally, like I mentioned in the previous video, we have 17 tables here. Okay, before I go and show you how we can do the scripting for these tables, first let me picturize how it is working. Okay, so we have so many entities here, and entities are like, entities means each entity is a table. Now each table is split here and there. There is no correlation between any of these tables. That was intentionally kept it for your understanding as we begin. Okay, now what we are going to do is we are going to now logically separate these entities so that you will get an idea of how they are logically grouped, and then we will show you how we can relate each table and how data are related. Okay, all right, now if you look at this diagram, okay, I have already organized the entities that you saw that was standing here and there. Okay, let me summarize this. So we have something called product, right? You go to amazon.com, everything that you buy is a product. Okay, whether Amazon sells or some other seller sells, doesn't matter, everything is a product. Okay, now a product will have categories, right? Categories means a cloth is a category, electronics is a category, you can name it so many things. So we have categories. So that's why we have a table called category. To keep it very simple, we have a category ID for that and then name. That's it. Now this category, there's a product. Okay, product will have the product ID, its name, price, the number of quantities that product is there. It's basically inventory. Given product, we have 100 piece left, means it will be having 100. So 100 only you can sell it. You cannot sell more than that. It will become an out of stock. Now the product is categorized. That's why we have something called category ID. Okay, bear with me. I will show you how it will get related to the tables. Now each product will have multiple images, right? You can see expand and see the images, right? That's why we have a table called product image that will have an image ID, product ID. And my idea here is having an image URL. I'm not going to upload this image and sitting in our deployed version. So instead we will upload it to the cloud, the Azure storage, and then that URL will be updated here. That's the idea behind this. Okay, so that these can be retrieved and we don't need to rely on the file systems. All right, now a product can have reviews. Like if you don't like a product, you go and scold them like anything, right? Or sometimes you price it like anything, whatever you wanted to review a product. We have a table called product review. See, product review will always be under a product. So that's why we have something called review ID. Any table that you have it, you will have a unique identifier for the table, which is here called review ID. Okay, and then this is related to a product, so that's why the product ID is coming here. Now this product can be reviewed by whom? User like us. We are humans, we are a user. That's why there is a table called user profile table. Will come there, but assuming there's a user profile table, that will have a user ID. So only a user can review a product, so we have something called user ID here. Great. And then the product can have some rating between 1 to 5, so we will have a column called rating, which will store 1 to 5. It could be anything. Now we will have some text describing this product is not good, this is not working, that is not working, or we can also say product is very good, whatsoever, right? The user used to do a review. That's why we have a review text. And then on what date it was reviewed. Very simple, right? So that's why this table is. Okay, now keep this aside for some time. Now, you know how they are all now related. Like as we speak, you have already figured out how it is. Similarly, now let's quickly go over these entities also. Now, there is a chance that a user can place an order. Order is what? Order will have multiple products, one or more products in the order, right? So you will add multiple items in Amazon and then you place an order, correct? So that's why we have something called order table. Will have again an order ID because order is placed by a user, so user ID, order date, and the total amount of that order. I'll come there, give me a second. And each order will have multiple products. That's why we have a table called order item. Order item again will have its own identity column called order item ID here. Like basically, there are two options you have. You can either create ID, just a name called ID for each table, will have a unique number to it, or there's another way of doing it, table name concatenated with the word called ID. So we have approached this second approach. The first approach has been followed in all of my earlier database design, but this is also possible. Alright, so that's why it's called order item ID. Great. Now again, this is what? Multiple products. So we will have an order ID that is associated with this order. There is a product ID because every item in the order will be associated with a product, right? Product is what you're finally ordering it. Great. And then how many pieces of that product? The same product can be ordered more than one times. That's why number of quantity. Price per order item. So if you have 2 items ordered, one item is $10, it will be $20 will be the price. Or maybe the price is just $10, the total cost will become the quantity into price will be the total cost. Alright, so let's keep it that way. Now similarly, when you place an order, order will undergo a status like order placed, in progress, shipped, delivered. All these are called statuses. So we have a table called order status. So again, status ID, order ID, status name. Simple, fair enough, so far good. Now logically, if you go to real, like I said, Amazon.com or go anywhere, right? You have something called coupons. Coupons is something is always possible, correct? So we have introduced a table called order coupon. Will again have an order coupon ID and order ID, coupon ID. Now, coupon ID, where is that coupon ID? So there is something called table called coupon. Here you go. This 10 entity which was having no friends is here. Alright, so there's a special design for this. See, coupon can be created based on a product or a category. Like for example, 10% flat discount on all clothing items, which means cloth is a category. For that category ID, 10% is a discount. So such kind of coupon can be created here. Okay, for now just imagine. Now, all electric kettles are all 45-inch TV. Okay, they're all different products. For particular product, we are able to create a coupon. So you order this particular LG 45-inch TV, you get 13% discount. If you try to order same TV with a different brand, you may not have coupon, so your coupon is not applied. Okay, so that's the idea. So in this one, not everything is mandatory. Either we go with product ID or category ID. Okay, for now, just understand the concept. I will go and teach you how this is related. Now, so that's why we have something called order coupon. So if somebody uses a coupon when they place an order, then that coupon which they place, right, like coupon code is like XYZ. XYZ is here. XYZ will, the content of that will have an ID, right? When they place it, we will go and retrieve and associate that order that, hey, this guy has placed an order. He has used this coupon ID. Because we can always go back and refer how much was the discount amount and all of those things, when it's expiring, all of those things. Okay. If you did not get this part, order coupon, let me know. Don't worry about now. As we progress, you will understand this. Again, there is an friendless person, like a payment information is standing here. This is again a table. This is only for now. This payment system itself is a big system, but let's not overcomplicate it, right? So we have a payment information. We are assuming after you place an order, user has paid the amount. Okay, so that's why it just has an order ID, the payment associate, the how much payment you have done, when you have done, what is the method. We are just simulating this. Okay, this is not the real payment information system that will be there in the real e-commerce system. We will have more entities to it, like Stripe and other things will come into picture. But imagine after you place an order, we will auto process the payment. Okay, assume that user has paid the amount. That's it. Now we're good. Stay tuned. Next is, you are the one who are the user who is doing all of these things, right? So as when you register, you will have your profile here, your display name, first name, last name, email ID, and we have something called AD object ID because we are going to use Azure AD B2C. I wanted to store the object ID of the user, which is in the Azure AD B2C, into my user profile table. And this time it will be interesting. I will auto do this when you log in or sign up itself. We will talk about it in a separate video. Don't worry. Stay tuned. The next is, the user can have a role, because when you have problem, when you call Amazon support team, they are also user. They are also logged into it. They will have some role to specially see your order IDs, to do some action on behalf of you, right? That's why we have introduced a table called roles. We'll have a role ID and a name. Okay, which means a role ID can be associated with the user. How do we do it? We create a table called user role. We associate this user ID and user role ID in a table. So for this table, the default identity column called user role ID, which is an auto incremented column. Now this table will hold information about the role of a user, which is role ID is coming from here, user ID is coming from here. Alright. Similarly, we can also record all the users activity. That's why we have a table called user activity table. Address. User can have multiple addresses, shipping address, or sometimes you can even order and ship to your friend address from your account. It's possible. So we will have multiple address, but only one address out of this can be a shipping address of a given time. Okay, that's why we have this. Now this wish list and cart is nothing but you try to add it to the cart, or you will have an option to do something called save it later. You remember that, right? So those kind of activities can be recorded here. Okay, so user ID, product ID, who wish to save it. That's why this table, and cart ID is like as and when you add to the cart, it will be recorded in the table. Great. So we're good. Now how do we do that? So we take this category ID here. Here is the important thing you should know. This is called inner join. Inner join means the data between these two tables should be present. If there is a category ID called 1, it has to be, this product has to be having one of this category ID. Okay, you cannot have a left join or right join, because here this relationship is mandatory to be an inner join. You cannot have any product that doesn't have category. That's the basic idea. That's why it's called inner join. Okay, so we have associated like that. Now product ID goes to product ID, This is okay. This is the difference. Okay. So now this may or may not be an join, because the moment you choose that a left join on the product, what does it mean? A product may be possible to have no images at all. There is no images available to view. It's possible, right? So this table is a child table. Which we are saying you have a parent. I mean, there is a parent which doesn't have child. It's possible. That's why there's a left join here. Okay, got it? Similarly, product review. There are products which may not have review. So now you know how to do it. Take the product ID and product, and it's going to be a left join on this table. See, if you read this, left outer join on the product table, which means same thing. This is a child, may or may not have data. So for good, we will not join this because we know it can be anything. Alright. Similarly, we can quickly join it. Order goes to order ID. Order will definitely have order item. An order cannot have no item unplaced. It's impossible that you can place an order without any product in it. So here we cannot have a left join. We should not have a left join. It should be an inner join. That's the difference between a product and this combination and this combination. Similarly, every product, every order will have a order status. You cannot have no status at all. So it has to be a inner join. Order coupon, possible. An order ID goes here, but it is possible that user has never used any coupon. You understood the difference? Great. Every order will go through a payment, so it has to be a join. So for good. Now, we can have this coupon here, but here it has to be a join. Reason because you cannot have something here which is not here. So that's the reason why it is in a join here. I believe you are following so far. Let me know if you have any questions right now. Now, role is a separate table, which is good, but role ID can be present here. It should be present here. But user ID, in this user ID, may or may not present because system did not assign any role for a given user. Sorry, it is here. So it has to be like this, okay? There is a left join here, like this is a parent, may or may not have child, but these two are like siblings. If there is a role ID here, it has to be here. User activity, great. Again, just guess what will happen. It can be a left join because user signed up, never did anything in his life. It's possible. So no user activity recorded. Address, definitely possible, but at a given point of time when you sign up, it is possible that you did not add any address or you later deleted all the address. It's possible. So this is a child doesn't have an address, like this is child of this table, may or may not have records. So for good, similarly, you see this goes to user ID, but wish list for a user may or may not present. That's why it's a left join. Similarly, this user ID also goes here, but may or may not present a left join. So far good, but if you consider this product ID should be definitely present here. It cannot be empty. Same thing goes here. That's it, guys. This is how the database is related to each other. This is called the relationship. Now, because data can be related, we are using a structured query language, which is nothing but SQL. What you do in Facebook, Twitter, and all of those social media stuff, right? You not only you, right? Anyone who uploads a drastic data, not all the data are structured. There are unstructured data. There are databases like NoSQL database, Mongo database, Cosmos DB database. They all support non-relational data, and those kind of data are stored in such database. For e-commerce, the SQL structured query language, right? That is RDMS, right? That is the one which is supported, and we have to go with that. Now, having said all of these stories, you know how to design it. Exactly same. You take any example, cake shop, this shop, that shop. You take any example. Now you try to correlate if you're already working in an organization. Relate this concept, the requirement based on what you're doing, the application is doing. The tables are related to each other. Okay, so now we have done a very beautiful job. This is good. Now what I can do is I can show you what that means, right? I will show you one simple example. We have created this relationship, okay, but how it is created using the script. We have table creation called create table category, followed by a column name of the table, data type, and any constraints. So in this case, we always have identity 1, 1, which means auto increment every number for every record. That is what it means. Okay. So for example, so you see this 1, 2, 3, 4, 5, 6, it's all auto incremented. Okay. Okay. Now Karthik, instead of 1, how can I increase a different one? You just need to say 10. So every number that creates is 10, 20, 30, 40, 50, like that. The difference between these two numbers will be 10, but logically we don't need that. Okay, but you know what this identity of this column means. Alright, so we are saying this is an integer column, and then it has an auto incremented value. It has a column called name. Maximum is 50 characters. It should not be null. That's the constraint. Here's the important thing. There's something called primary key. Primary key means you know the data cannot be null and it has to be unique. Okay, the column, the moment you say primary key for this column, it will be unique, no null values. You can define this primary key here instead of this. What will happen? The only difference is when you create this table, okay, what will happen is I'll expand and show you. Right now, it was like this, right? See, this is called named constraint. Okay, we are saying create a constraint named this, and that constraint is the primary key for this column. This is the right way of doing, because any key that you do directly here will not have this name. Randomly it will be generated, which means every database that you create for different environments will have different names. Ideally, it's not a good idea of doing it. We should be a named constraint. That's why we are defining a name like pk means primary key underscore table name underscore column name. That's the format. Okay. Now, next is product table. Same logic, same explanation. The only difference is after this. So let's go one by one, right? Product ID. This is the auto incremented column. Name. We are saying it should be maximum of 100. It should be not null. Price is the decimal. Quantity is int, not null. You cannot have zero product, or at least null products, right? So category ID. So now we are saying there is something called category ID and int. This one should definitely match with this one. Zero excuse. It has to match. The moment it match, if it matches, it nice. Okay. You can have a different name, but it's not a good idea of doing it. It always has to match. So this is how it works, right? The primary key of a primary table, parent table, goes as a foreign key in the child table. So this is a foreign key. This is called primary key. How do we define this as a foreign key? This is how we define. We define a constraint. Fk is foreign key underscore table name underscore this table name. We are saying there's a foreign key which is referencing this one. So this category is this category, but we are saying, hey, reference this category in this category table in category ID. This is the way you define it. That's it. Now, if you understood so far, this is what is done for all of these tables. Okay. The only thing that you will see more here is order will have one primary key, one foreign key, but order item will have two foreign key because order ID is also a foreign key column. Product ID, which is also a primary field in the product table. Okay, but trust me, other than that, there is no special stuff here. The only thing other than this that I can think of is a constraint called default constraint. Let me quickly check. Okay, so we have something called default constraint. Okay, so for user profile, right, I'm saying if the display name is not given, just mark this as guessed. So we are saying it's not null, which means user has to give. What will happen if user doesn't give? We cannot save the table, right? Record. So we add a constraint as a default constraint, say default guest. If they don't save it, we save it as guest. That's it. What else do I have anything special other than this? So once you design this the way I explained, right, all of this table, this is what we will get. This is what we will get. Okay, now I'll show you something interesting. See, this is the query wizard. So if you come here and go to query wizard, okay, actually I will select only important tables. So I'll select only important tables. We know what we're doing. Okay, so order item, order products, product. That's it. I'll add only 4 tables for now. See, once you have defined it properly in the query wizard table, the links will come automatically. I showed you how it is linking, but actually the links will come automatically based on how we defined. Okay, see, order item will definitely have a product ID. It has to be in a join. Orders will definitely have order item. It has to be in a join. Status also is mandatory. It's in a join. Okay, this is important, and this is something that you can use. So you can say, I want this, I want this, I want this. You see this query is getting created, and you can come here and say filter product ID in 2, 4, something like that. The moment you add this, it will have a var class created. So if I say okay, interesting. I have some records. Great, because I was experimenting all of these things. Okay, great. So I wanted to keep it short. I hope you understand this e-commerce database design. This is how we would design a database for a robust application, and we are going to use this for our application. I hope you enjoyed this video. This is exactly same how you design for any other applications. Do let me know in the comment section if you have any questions, and I will definitely see you in the next video shortly about the Web API .NET Core 8. Alright guys, thank you. See you in the next video. Thanks for watching. If you found this video helpful, please give it a thumbs up and subscribe to our channel for more tech tutorials. And don't forget to hit the bell icon to get notified when we post new videos. If you have any questions or suggestions, leave them in the comments below. Happy coding!